The headline screams a 1,050% price hike, but the engineering reality is far more dangerous for your AI budget than simple accounting errors. When Broadcom's proposed licensing model turns software-defined virtualization into an unaffordable tax on compute, it exposes a critical flaw in modern infrastructure. We are building expensive GPU clusters atop legacy architectures that charge us twice, once for the silicon and again for the license overhead. This isn't just about IT costs. It is a signal that legacy lock-in is making AI training and inference economically unviable without an architectural pivot to cloud-native containerized efficiency. The immediate shock of a 1,050% increase forces us to ask why we are paying so much in the first place. The answer lies in how we have layered software over hardware for decades. We treat virtualization as a neutral layer that simply manages resources, but in high-performance computing environments driving modern AI models, this assumption is failing catastrophically. A study from Oxford University on anomaly detection in AI systems highlights that reliance on full-stack visibility through traditional virtualization layers often blinds operators to the very hardware inefficiencies they are trying to manage. The research found that minor power misconfigurations or software-defined bottlenecks can cause up to a 1.5 times slowdown in execution time. Think about what that means for your production environment. A single GPU unit costs tens of thousands of dollars, representing a massive capital investment. If the virtualization layer sitting on top of it introduces even modest latency due to misconfigurations or overhead, you are effectively wasting those resources without adding any value. This creates a silent killer where you pay premium prices for hardware performance while simultaneously surrendering significant efficiency to software layers that offer diminishing returns in the AI era. The result is an infrastructure model where the cost of running the management layer becomes comparable to, or even exceeds, the value delivered by the compute itself. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This brings us to the concept engineers call legacy lock-in. It describes a situation where algorithms are built for yesterday's chips, while new silicon optimizes only for specific workloads that do not align with generic virtualization demands. We are essentially trying to run Formula One cars on roads designed for horse carriages, and now the toll booths have doubled, tripled, then quadrupled in price. The industry has recognized this misalignment as a primary bottleneck for progress toward 2035. A consortium including Yann LeCun from Meta AI and Jason Kong argues that to survive, we must shift from unbounded compute consumption to intelligence per joule. This requires rethinking memory-centric designs and moving away from generic virtualization layers that add latency and overhead. The economic reality of this transition is stark. Training a single frontier model consumes energy equivalent to hundreds of households, with data centers increasingly rivaling nations in total power demand. In an environment where the margin for inefficiency has vanished, continuing with traditional hypervisors risks making your infrastructure unaffordable as model sizes grow. The proposed cost increase forces a binary choice: absorb this legacy licensing tax, or migrate to architectures where software overhead does not eat into the return on investment of expensive GPU hardware. Fortunately, there is engineering proof that bypassing these layers yields tangible results. New frameworks like Migratable Velocity Virtual Machine demonstrate the viability of hardware-native deployment. These systems use WebAssembly-based containers with hardware enclaves to achieve 8.9 times speedups through speculative execution compared to standard virtualized methods, while maintaining failover times as low as 200 milliseconds. This proves that containerized hardware-aware architectures can drastically reduce the hidden tax on compute resources that legacy models impose. The data shows that when you remove the abstraction layer between your code and the silicon, performance scales in ways that traditional virtualization simply cannot match. For developers and data engineers managing production AI stacks, this news serves as an urgent audit trigger for your infrastructure strategy. If you are currently running heavy large language model training or inference workloads on legacy virtualized environments like VMware, you may be paying a double tax. You pay premium prices for GPU hardware while surrendering significant performance to software licensing layers that offer diminishing returns in the AI era. The takeaway is not just financial, it is architectural. Continuing with traditional hypervisors risks making your infrastructure unaffordable as model sizes grow. Engineers must evaluate moving toward cloud-native, container-based architectures where compute efficiency and agility are prioritized over legacy compatibility. The market projection reinforces this urgency. Demand for cloud-based AI resources is expected to grow by 30% annually until 2030. If you lock your architecture into a licensing model that scales inversely with the value of your hardware, you will find yourself unable to scale your business operations fast enough to meet demand without breaking your budget. The goal of achieving 1,000 times efficiency improvement in computing power relies on co-designing software and hardware together, not layering generic management tools over specialized silicon. This shift represents a fundamental change in how we view the cost of compute. It is no longer sufficient to look at the price tag of a license or the sticker price of a server. We must measure intelligence per joule. Every dollar spent on silicon must translate directly into inference speed rather than licensing fees for legacy compatibility layers that add latency and complexity without value. The path forward is container-native, hardware-aware deployment where software overhead does not eat into the ROI of expensive GPU hardware. The time to act is now before the next price adjustment locks you in further. Audit your stack today. Ask yourself if you are betting on a virtualization layer that costs more than the hardware it manages. The engineering consensus points toward a future where efficiency and agility win, leaving legacy lock-in behind as an expensive relic of a previous era of computing. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.